Okay, sir. We are live on YouTube.
Dr. Thipse, sir, can we start our session?
Yeah.
Okay. Over to you, Rehan, sir.
Yes, thank you, sir. Am I audible, sir?
Yes, sir.
Yes, yeah.
Good morning to one and all. I, Professor Rehan Siddiqui, on behalf of NCT's Rajiv Gandhi Institute of Technology, Department of Mechanical Engineering, welcome you all to online one-week short-term training program on recent trends in renewable energy sources and its applications. Our speaker for today's session is Dr. S.S. Sttp from the Automotive Research Association of India, Pune. Dr. S.S. Sttp has done his master's in thermal sciences from Bradley University, USA, and PhD in the area of alternative fuels and combustion from the New Jersey Institute of Technology. He has a rich research experience of 23 years in the area of alternative fuels. He is the Deputy Director and the Head of Engine Development Laboratory at the Automotive Research Association of India, Pune. He has published several books and has more than 100+ articles published in national and international conferences. He has more than 6 patents to his credit. I welcome you, sir, once again, and request you to enlighten us with your knowledge and experience. Over to you, sir.
Yeah. So thank you for the kind words of introduction. Today I'll be talking on the alternate fuels. So I will just share my screen. Hope my slides are visible.
Yes, sir. It is visible.
I'll just put it in full screen mode. Okay. So first of all, thank the organizers for giving me a chance to be here. And I'll be very happy to share my thoughts on a very important subject, that is the alternative fuels. And basically, this topic is of great interest now to the country. And I'll just go through why and what are the new technologies and regulations coming in this area. Just a minute. I think that slide seems to have been stuck. Hold on. Just give me a minute, please. Okay. So now let me go back to escape. Share the screen. Yeah. So this is my profile. If you see, I'm working in this alternate fuel area since last more than 22 years. And I work with several government committees. So I represent ARI on various government committees, and hence I get a very good perspective on the alternate fuels. I'm also chairing the Indian committee BISTD 26 on components, and I represent India on the ISO committees. So that gives me a very good perspective on all what is happening in different sectors on the alternate fuels. Seems to be some problem with the presentation. Just give me a minute.
Your screen is visible, sir. Your
screen is visible. It's not changing the slide. I don't know when it's going. Okay, it is coming. Sorry. So going ahead, what are the mobility options for India? Now, there are 3 options. One is the alternative fuels, second is electric vehicles, and third is our conventional fossil fuels. So these are the fossil fuels. When I say fossil fuels, I'm talking about our diesel, gasoline, which is the mainstay of our transportation. And competing with it is alternative fuels, that is gas and other alternate fuels. I'll talk about it. And also now, electric vehicles are coming. So e-mobility is a third option. So all these 3 options are now competing with each other. And what is the present need for alternate fuels? So in the first thing is the vision Atmanirbhar Bharat, means we need to be self-reliant for fuel. We are also worried about greenhouse gas mitigation. So in terms of reducing CO2 globally, that is a greenhouse gas, global warming concerns are there. Then there is this Paris COP agreement, which we have signed. that we have to ensure that the temperature is below 2 degrees. So that is an international commitment. For that, we need to really move away from carbon-based fuel sources. Then local pollution is there. All our cities are highly polluted. So how to reduce the local pollution of CO, HC, NOx, PM, this is also concern. And of course, the Indian economy, we are spending a lot of money importing the crude oil, and that has to be saved for the country. So boosting the Indian economy is also one of the need of the hour. Now, if you see the ARI role.
Sir, hello, sorry to disturb you, sir.
Yes.
Sir, your PPT isn't visible.
Oh, sorry. Okay, let me see. Oh. Let me share it once again. Give me a minute, please. Okay, share screen. Share. Is it visible now?
Yes, sir. Yes, sir. It is visible.
I'll try to give in this mode only because I think when I go to the full screen mode, there seems to be some issue. Anyway, so I was just mentioning about the present ARI role in alternate fuels. So prior to that, I talked about the need for the alternative fuels, the 5 factors, including Atmanirbhar Bharat, greenhouse gas reduction, Paris COP agreement, local pollution, and boosting the Indian economy. Now, if we go to the ARI role, as I am a representative of ARI, we have been working in this area for so many years. So we do R&D projects, we do regulation formulation, we do the CMVR certification of gensets and vehicles, we do training and consultancy. So these are some of the ambits in which we are working in alternate fuel. So we are based in ARI, Pune, Kothurud, and we are also having 2 campuses in Chakan. These are like 40 kilometers from the main campus. Now coming to what are the alternate fuels which have been notified in India? So there are many fuels which have been notified by the government of India. Normally when the fuel is notified, they issue a number and a gazetted statutory regulation, GSR as we call it. And that establishes the fuel and adds it into the central motor vehicle rules. So all the certification is done as per central motor vehicle rules, and all the fuels are notified in the central motor vehicle rules. So in this case, these are the different numbers and the names of the fuel which have been notified in CMVR. So I will just go through it one by one. So bio-CNG, that is biogas, has been notified as a fuel. Biodiesel, that is B20, 20% blend, 100% blend. Compressed natural gas, then dimethyl ether, that is a synthetic fuel. Then diesel plus gas, diesel CNG, diesel bio-CNG, diesel LNG, ethanol, so E20, E85, all E100, everything is notified. Hydrogen, hydrogen CNG, LPG, LNG, that is liquefied natural gas, and methanol. So methanol and its derivatives, M15, M100. So these are all the alternative fuels which have been notified by the government for use as automotive fuel. That doesn't mean that all the fuels are present in India, but they are allowed by law. So tomorrow, any manufacturer wants to introduce these fuels, it is possible for him to introduce these fuels in India. Then what are the different categories of alternate fuels? Now, I gave you the whole bunch of alternate fuels, but you can classify them in 4 different buckets. So the first is naturally occurring gaseous fuels. So these are in nature itself, they are available. You don't do any processing for that. So like natural gas is there, so CNG and LNG, all these are naturally occurring fuels, or also termed as gaseous fuels. Second thing is known as the biofuel. Now biofuel, word bio means it is coming out of a living creature, a living organism. So this category of fuels are the fuels which are, one can say, derived out of living organism. Either some plant or animal is the base of that particular fuel. For example, ethanol, you derive it from the sugarcane. So the sugarcane plant is the basis of that. Okay. Then bio-CNG is there, methanol is there, ethanol is there. All the alcohols, they are derived from grains. Grains are again a byproduct of plant. So all these are all living organisms, and the fuel is extracted out of it. That's the definition of a biofuel. So all alcohols are biofuels. Then coming to the third category is hydrogen. So hydrogen per se exists in nature, but it is not available per se as hydrogen. It is available as a always a compound along with either oxygen as water, ammonia, or hydrocarbon. So there is some either carbon attached to it, or nitrogen attached to it, or oxygen attached to it. So hydrogen is a fuel which is always associated with a particular molecule. So hydrogen is one fuel which is important because it is the cleanest fuel. It's zero carbon fuel. So hydrogen is the third class of fuel. Then comes the synthetic fuel. Now this synthetic fuel is something which is not available in nature. So it is artificial. Like the first class of fuel was naturally occurring. This is man-made. This is made in a lab. This is not available in nature. You have to produce it with some designer properties. So that is called a synthetic fuel. So you can divide alternative fuel into all these four categories. And for all the four categories, there is a front runner. So for the natural gas category, it's CNG and LNG is a front runner. For biofuels, ethanol is a front runner. Hydrogen, pure hydrogen is the front runner. And the synthetic fuels, DME is a front runner because that is the fuel which is notified in India. Now coming to rules and regulations. So there are four types of rules which are important. One is the vehicle approval rule. That is, how do you approve a vehicle for use in India? So there the CMVR rules 1989 are applicable. So that ARI does the vehicle approval. Then you have fuel sale by OMCs. So this is the sale of the fuel. This is by the petroleum rules. When all your petrol, diesel, gas, everything is sold as per the Ministry of Petroleum rules. Now then comes the station, the dispenser, means the entire gas station, the tanks, the storage, that is governed by the PESO, Explosives Department. And then comes the cylinder and the valve. This is fitted on the vehicle. So that is also as per the gas cylinder rules. So this is a different authority. So these are the four different authorities which will govern the regulatory scenario for alternate fuels. Now, how is the path for alternative fuels? How is the roadmap going on? So in this case, you have, first of all, we started with petrol and diesel. That is the conventional fuels. That is high-speed diesel and motor spirit. That is gasoline. Okay. So we started with petrol, diesel. Then we shifted to the gaseous fuels, including CNG and LPG. And after that, we slowly started introducing biofuels. So biodiesel, ethanol came into the picture. Now we are in the second generation biofuel. So we are into the biofuels derived from cellulose and other feedstocks. So this is the stage where we are in. And in the future, we will be going to synthetic fuels. So first synthetic fuel has now already entered the country. And then slowly more and more synthetic fuels will come. And lastly, hydrogen will be the ultimate goal for any fuel because it has no carbon. So all the roadmap says that it will go to hydrogen in the end. Then SIAM is a body of Indian automotive manufacturers. They established a white paper which gave all the different technologies, and then they recommended certain technologies for different vehicles. So they clearly highlighted what kind of market this is, how what you call the different share of the different vehicles is, how the alternate fuels will be applicable, and they came up with a matrix, entire matrix of technologies. So they put all the fuels which were notified in baskets, and they recommended some of them for different applications, and all the vehicle technologies were listed: two-wheelers, cars, three-wheelers, buses, trucks, LCVs, and then they recommended different fuels for different technologies. And this kind of a guiding document was given. This is available on the internet. If anybody is interested, they can see this roadmap, which is widely available. So this is a very good document which gives kind of a guideline on what fuel to use for which segment. Then there are some new applications which are opening for alternate fuels. Traditionally, it was restricted only to, one can say, road and other applications. But now tractors are coming, off-highway vehicles. Then aviation, aircrafts are also using biofuels. Railways is using CNG and other biofuels. Marine, shipping applications are using different fuels. off-highway excavators are using different fuels. Then your generator sets are using different fuels. So all of these are trying to give you different applications for alternate fuels, which were earlier not there. So all these sectors which I am showing, they were earlier always dependent on either diesel, which was based on a fossil crude. And as you know, the prices of fossil crude are increasing all the time. And hence it is no longer affordable for all the applications to go on the fossil fuels. So we need alternatives, and alternative fuels like CNG, biofuels can fulfill this need and replace them slowly in these applications also, apart from, of course, the automotive applications. Then another big debate which is going on in the world, if electric vehicle is coming, will the IC engine survive? So whether there is a requirement of engine and fuels. So I am just quoting a study here from Arthur Little. This is available on the internet. You can see this. So what Arthur Little has done, he has compared electric vehicle with the IC engine vehicle. And what he mentions that he has compared both these technologies, and he has made three areas. So one is cost of ownership. So what he says is the electric vehicle is more expensive from ownership point of view. But global warming potential, electric vehicle has less global warming potential. So that it scores in that aspect. And secondary environmental impact. This means that suppose the end of life is reached, so you have to throw away the battery. So all that stuff means disposal of the vehicle. So the BEV has 3 times greater human toxicity potential. Means what it says is there will be some issues with respect to disposal of electric vehicles. So these are some of the different areas which we are working on. Now, remember, as if you consider the average of electric vehicle, right now electric vehicles are efficient, but the IC engine is also evolving because people are working on IC engine, improving the fuel efficiency. So people are always concerned with kitna deti hai, what is the mileage, you know. So that is something which is very important for IC engine. And in that case, it is predicted by 2040, the IC engine also fuel consumption will be as low as 30 grams. So right now it is 97 grams per kilometer right now. But in the future, it will even come down to as low as 30. And in that case, then the IC engine will be also competitive with electric vehicles. We should realize that as the electric vehicles are growing, so also IC engines are also adapting. It is not the end of the road as of now. If you see, our thermal efficiency is hardly 44% for IC engines. Still, there is a lot of what you call growth potential, and there is ample research required. So IC engine is not going to die anywhere. It is going to survive by adapting. So that is the message which is being given, that don't despair that all electric is coming, so engine and fuel has no future. Nothing like that is going to happen. So that is the message which we are giving. Then coming to the different segments now, I will first focus on the gaseous fuels, starting with the compressed natural gas. Now, this was way back in 1991, it was notified in India, and even for BS6, it is notified. These are the standards below which I have written for the different components. These are the Indian standards which are readily available. Then what is the advantage of CNG? Basically, it's a low carbon fuel. It is widely available, lower particulate, it's renewable, and it is extremely cost effective. You know that CNG is hardly 40 to 50 rupees per kg, whereas petrol diesel is now 100 rupees. So almost half the price. And it's definitely something which is growing in India. There is a lot of pipelines being laid in India. You can see that infrastructure being laid. And in that, there is almost 11,000 kilometers of natural gas pipeline being laid right now. And around 10,000 plus CNG stations are planned. 15 million vehicles are expected by 2025. So it's a big growth story for CNG in India. Many pipelines are already in place. Many more are planned. So even the east part of the country, the southern part of the country will be covered with gas pipelines. So that is definitely going to happen. Now, if you see the what you call applicability of CNG for vehicles, right now, CNG is most useful for cars, three-wheelers, and buses. Okay, so this is being used for these 3 categories, and these are the on the right side. You are seeing the properties of CNG. Now, if you see the classification of the vehicles, you can classify CNG vehicle as dedicated fuel. You can classify it as biofuel, or you can classify it as dual fuel. What is the difference? When I say dedicated fuel, it means CNG only. When I say biofuel, it means CNG and or gasoline. So I can use CNG or gasoline. In the sense, I can use only one fuel at a time, but there is option for running on two fuels. So that is the biofuel operation. Earlier, this was very popular when CNG was not fully available. People were worried, if we don't get CNG, how do we run the vehicle? So that they can run on gasoline and switch to CNG when available. But now that issue is no longer there. So people are preferring dedicated fuel vehicles. There is another third category called as dual fuel. This is typically suitable for heavy duty applications. In this case, it is meant for trucks. So diesel plus gas together used in a diesel truck. That's a dual fuel technology. So I'll talk more on the dual fuel in the subsequent slides. So going ahead, ARI has done excellent work on this, and recently we completed even a BS6 engine on CNG with all the different calibrations, EGR and everything. So CNG engines are easily meeting BS6 norms, and there is excellent growth potential in this area. Now coming to the next fuel is the bio-CNG. Now this is the what you call rural aspect of CNG, that you take waste and you can refine it to form bio-CNG. So bio-CNG is one fuel which is a derivative of biogas. All of us are aware that when the waste decomposes, it forms biogas. And if you purify the biogas, it becomes bio-CNG. So these are the standards for that. And a lot of applications on bio-CNG being developed, including tractors. So the only issue with bio-CNG is that you need to clean the biogas. You cannot directly use biogas as it is. You have to remove the carbon dioxide, you have to remove the hydrogen sulfide, and you have to remove the moisture. And once you do that, then the biogas becomes bio-CNG, or in other terms, it is also called as CBG, compressed biogas. And that compressed biogas is as equivalent to CNG because it is similar in characteristics. And with that, you can have different applications. Now, typically, this is a rural fuel because majority of the agricultural waste is being used for bio-CNG. Typically, the people, they burn that waste and that causes air pollution, as is the case in Delhi every time. There is smog created because farmers from Punjab, they will burn the waste. So instead of burning that waste, if we can convert it to biofuels, that will be a very good source of energy. So that is the bio-CNG, and it can be used for rural applications like tractors, generator sets, rural electrification, pump sets. So all these things can run on bio-CNG. Fuel can be produced there itself and used there itself. So it's a rural fuel. It's one of the very good fuels and permitted by Government of India. Next is LNG. Now this is another form of natural gas, wherein CNG is a compressed natural gas in the sense it is a gasified form. But if you may, use very low temperatures like cryogenic temperatures, you can go to LNG, which is a liquefied natural gas. So that you have to, the gas becomes a liquid at -162. And this liquid gas, what is the advantage of making it as a liquid? You can store it in the vehicle in a greater range. So you can increase the range of the vehicle by having a storage. So in this case, you can use this for buses, you can use it for trucks, you can use it for LCVs, all these different applications, LNG can be used for the different vehicles. And it is a very compact storage, just like petrol and diesel, it's a very compact tank, but it is a cryogenic tank, so it is slightly expensive. So LNG is being looked upon as one of the fuels for the highways, because in the cities you have CNG, in the rural part you have bio-CNG, but along the highways where you have long distance trucks and buses running, there LNG is the best fuel for the application. So here you can see the plan of LNG. Right now LNG is being imported from some countries. So typically all the ports of India are having LNG terminals. So there are these different terminals in Gujarat, in Dabhol in Maharashtra, then Kochi in Kerala, Ennore in Tamil Nadu, then Kakinada is there in Andhra Pradesh, and Haldia in Bengal. All these places, the ports are there, and there the LNG terminals are coming. And with this, all the different cities adjoining these ports will get LNG fuel. And we can also gasify LNG. And once you gasify LNG, you can then make CNG out of it. So that is very much possible. This is how a typical LNG system is on the vehicle. So the LNG tank has to be fitted on the vehicle. There are many safety gadgets, including pressure regulator, excess flow valve, and you have to put that system onto the vehicle, adapt it, and then you have to take care of the safety and other aspects. So there are many possibilities because LNG is, as I said, promoted as a highway fuel. Trucks and buses are the ideal candidates. And definitely many more stations are coming up. There is also talk of LNG corridor, where some certain sections of the highways will have LNG stations. So a lot of activity in this respect. One vehicle is also certified on LNG in Kochi in Kerala, and LNG vehicle is already running. So many such vehicles are expected. Then diesel gas, diesel CNG, dual fuel is another technology which I talked earlier. So this is another technology which is of interest. Now, what is this dual fuel technology? Now, typically in a gas application, you need a spark ignition engine. But suppose you have a compression ignition engine and I want to use natural gas into it. In that case, if I directly use natural gas in a compression ignition engine, it will knock. There will be knocking phenomenon. But how do I solve this problem? Suppose I use diesel plus gas together. In the ordinary diesel engine, you have air coming inside, getting compressed, and the diesel is injected, and the whole mixture is ignited. In this case, you have diesel plus gas together coming inside, and it is getting ignited. So air comes in, the natural gas comes along with the air, but the heat of compression does not ignite the natural gas and air. When the diesel is injected, then the diesel ignites the natural gas and air. So total mixture is ignited by diesel. So you can run this on the diesel plus gas together. Advantage is you don't have to make changes in the engine, no need of conversion of CI to SI. Also, you can substitute diesel by gas up to 85% roughly, but you cannot run on 100% CNG. You can run on 100% diesel, but you cannot run on 100% CNG. So there should be partial replacement and the engine remains as a diesel engine. But what is the advantage of adding CNG in diesel? The pollution comes down, the emissions come down. So advantage is emission come down. Then you get operational cost benefit because as I mentioned, gas is cheaper than diesel. So you get less pollution, operational cost benefit. At the same time, you are not changing the engine operating characteristics. So all these are advantages of dual fuel technology. Now, ARAI developed a lot of applications for dual fuel, heavy duty, SUVs, tractor, off-highway, all these projects we have done in the past for dual fuel. Also, the rules and regulations, ARAI played a major role. So now, this is one very unique application, a construction equipment vehicle on dual fuel. Now, construction equipment vehicles are typically all diesel-based. So these are forklifts, then they are excavators, and then they are earth movers, and all kinds of dumpers. So all these earth moving equipment are typically ideal candidates for dual fuel because you can use some gas in that and that will help you to reduce the consumption of diesel and also save money. So there are countries like Thailand, New Zealand, Australia already using this kind of technology. But India also, it is permitted. First vehicle of its kind has already been launched by JCB. Okay. Then coming to biofuels. Now, next area of interest is the biofuels. So here we will talk about more on the biodiesel, ethanol, methanol, and different biofuels. So the main thing here is the biofuel cycle. Now, biofuels are called carbon neutral. Why are they called carbon neutral? Let us understand. So biofuel are very important when we talk about reducing CO2, when we are reducing, meeting the Paris Climate Agreement. So in this case, any plant, when you are growing any plant, any oil crop or any kind of thing, that plant is going to absorb carbon dioxide from the atmosphere for growth, photosynthesis reaction. And then it will produce seeds. Those seeds are taken and the oil is extracted. And from the oil, the fuel is extracted. Now, this fuel has to be used inside the vehicle. So, if the fuel is burned in the vehicle, it will again produce CO2. But remember, when the plant was growing, it had already absorbed CO2 from the atmosphere. So it is simply giving back the CO2 back to the environment. It is not adding to the CO2 tally. So it is called carbon neutral. It absorbs CO2, it produces CO2. Whereas fossil fuels are directly adding CO2 into the atmosphere. So they are not carbon neutral, but biofuels are carbon neutral. And hence their role is very important in promoting low carbon fuels. So these are very, very important aspects. Then they are renewable and they have some shelf life issues. So biofuels are being looked upon in India in a major way. Then we have the biofuel policy, which was released in 2018. So in the biofuel policy, the discussion was to have ethanol blending with gasoline. So initially target was 5%, then they made 10%, now they are talking 20%, and they even preponed the target from 2030 to 2025. This is a very recent addition. So now ethanol blending is promoted in India, and they are also not only generating ethanol from sugarcane, they are also generating ethanol from damaged food grains. They are also generating ethanol from corn. So all these things are allowed. And with this, there will be additional generation of ethanol in India. Now, there is also a parallel talk about methanol also. So people are talking about M15 methanol blending as recommended by Niti Aayog. CIAM is recommending M3. And at this present, E20 is being recommended as a ethanol fuel. Now, recently, I don't know how many of you follow it, but the PM launched the Ethanol 20 program on the World Environment Day. And in that, this is the map how we are going to follow now. Today, at this present moment in 2021, we are 8.5% blending is being done. So by 22, 10% is predicted. Then after this, by 2025, we are predicting almost 20% blending of ethanol. That is what is the plan. So we have to see how we are going to stick to the plan. But one thing is clear that the ethanol production is going to increase day by day. Then coming to the notification and standards. So here, ethanol is already notified as automotive fuel. All the different standards are already in place. 20% ethanol is allowed, 85% is allowed, 95% is allowed, and even E100 is allowed. And all the standards, rules, and regulations are already in place. There are different technologies for ethanol, which I will talk now. So first thing is a very interesting technology, compression ignition of ethanol, ED95. So this technology is where ethanol for buses, trucks, and LCVs. Now, normal ethanol you can blend with gasoline and use in two-wheeler, three-wheeler, four-wheeler. Everybody knows that. But this is a very unique technology. With additives, 5% additives and 95% ethanol, you can run even a diesel engine with a very high compression ratio. So this kind of technology has been brought in by Scania, where you get an engine with a thermal efficiency equivalent to diesel using ethanol. So it's practically a pure ethanol engine. And there are buses running here in India in areas like Nagpur, where ethanol buses are already running. So these are the vehicles which are already running on ethanol. And these are very popular in Nagpur, and more buses will be introduced in the long run. So another fuel which I mentioned to you, apart from ethanol, is methanol. So this is another fuel which has been promoted in India. Now, why this methanol is being promoted? So it is basically another fuel which is produced from either natural gas or it is produced from coal. So coal is one of the major source of methanol, and high ash coal is amply available in India. And high ash coal is something which is not suitable for power generation. So that coal can be diverted for methanol production. So this is the plan of Niti Aayog, that you have waste biomass, you have high ash coal, which is not suitable for any other application. So why not use it to convert to methanol and then use it as a vehicular fuel? Only issue with methanol is it is toxic. So there are some concerns regarding its use. But if you follow all the safety procedures, there should not be any issue as far as the methanol use is concerned. So the Niti Aayog is talking about a methanol economy. What is a methanol economy? Means you take different sources like coal, which I mentioned, biomass is there, or even capturing atmospheric carbon dioxide. And then you convert it into syngas. Syngas is CO plus H2. And then you can generate it into methanol. Now, methanol itself is a very valuable chemical. From methanol, you can use it as a fuel, or you can use it as a chemical also. And you can generate many other chemicals like olefin, formaldehyde, acetic acid from methanol. And also many other fuels can be generated from methanol. So you can use methanol directly as a fuel. You can go to gasoline. You can use DME. So DME is dehydration of methanol. Then you have MTB, methyl tertiary butyl ether. Then you have ethanol also. Many other fuels can be generated from methanol. So methanol becomes a valuable feedstock. And that becomes one of the basis contention of methanol economy. Now, in ARI, we did work on methanol blending with gasoline, 15%. And our work was submitted to Niti Aayog. We ran vehicles on M15 Blend, and all the data was shared with the government. Coming to the next biofuel, that is biodiesel. Now, biodiesel is a esterified vegetable oil. So it is a fuel which is made out of vegetable oil. And there are many standards and notification already in place for this fuel as well. And this is one of the fuels which was earlier in the last 20 years being talked about for a lot for the areas where there was less income as far as agriculture was concerned. So the oil seeds are available a lot in India. So the oil had to be extracted, and then the biodiesel had to be prepared and then used in different vehicles. So biodiesel is a esterified from vegetable oil, and it is used where vegetable oil is abundant, and with that you can generate a fuel which can be used in an engine, and it doesn't require any modification in the engine, and it is best suited for larger engines. And the advantage of this biofuel is that it will reduce CO, HC, and PM emissions. And there are certain demerits also, but many other countries have been using this fuel, like Brazil, USA, Argentina, and they have kind of solved all of these issues. So in India also, B100, we already worked on this, and many applications on B100 are there. Unfortunately, the fuel itself is not available to a greater extent, so we are not able to use it. Biodiesel is ideal fuel for buses, trucks, and commercial vehicles. It can be directly used as B100 or blend with diesel B20. It has excellent lubrication properties, but as I mentioned, availability is poor, and hence the blending is very less. So these are the issues with biodiesel technology, but people are working on it, and many other rural applications on biodiesel like tractors and all are being developed. Now coming to the third basket of technologies, which is hydrogen. Now, if you say hydrogen technology, there are three aspects to it: use as a pure hydrogen, or use as a blend with CNG, hydrogen CNG, or use in a fuel cell vehicle. So all these three aspects are the branches of hydrogen. So if we go ahead, if we go to the next slide, we are talking about hydrogen fuel as a renewable fuel. Now, this also hydrogen is a renewable fuel. Why we call it as a renewable fuel? First of all, it is zero carbon. And when you can generate hydrogen, you use it in a particular application. Let us say you use it in an engine or a fuel cell. Hydrogen is converted to water. And that water, when you split with the help of electricity using electrolysis method, you recover hydrogen back. So it's a cycle. Hydrogen you burn to get H2O, H2O you split to back get H2. So this is a cycle for hydrogen which is there. And with this you can imagine that this fuel has a perpetual life. There is no end of life for this fuel, because it is perpetually existing in nature and it can be generated very efficiently. So there are the advantages of this particular hydrogen. So it is called one of the future fuels, or people say that all roads lead to hydrogen in the future. There are three types of hydrogen. That is a classification which has now been given: gray hydrogen, blue hydrogen, and green hydrogen. So when I use renewable energy, whether it's a water-based or wind-based or solar, and I split water into hydrogen by electrolysis with no carbon emission, then it is called green hydrogen. Suppose I split natural gas to generate hydrogen and I ensure that the CO2 is not released. I capture the carbon, but I split natural gas, then it is called blue hydrogen. And if I split natural gas and release carbon dioxide into the atmosphere, it is called gray hydrogen. So India, we are focusing on the blue hydrogen and the green hydrogen, which is of greater importance for us. Now, hydrogen application, you can use it in different applications. So the rules and regulations for hydrogen are in place, and application of hydrogen include car, three-wheeler, buses. Okay, different applications are there. These are the properties of hydrogen. It is one of the best fuels. It's a clean burning fuel. As I mentioned, only water is produced and hardly any emissions because there's no carbon at all. So no question of COHC, CO2, nothing is there. It's a very clean fuel. Only issue is the safety aspects, which has to be taken care because the safety hazards are very important. Now, in terms of the use in IC engine, you can use it as a neat hydrogen, 100% hydrogen. You can use it as a supplementation with petrol. You can use it as hydrogen plus CNG. You can use as dual fuel. Everything is possible as far as the hydrogen use is concerned. As I mentioned, there are some safety serious issues with hydrogen. We know hydrogen is a very good fuel, but why we are not using it now? Because a lot of research is required to really solve all these technical difficulties, include the wide flammability limit, then pre-ignition issue is there, then flame speed is very high, then ignition energy is very less. It is difficult to detect leak because it is colorless and odorless. It causes metal embrittlement. Many issues are occurring in hydrogen, and there is also safety issues like backfire, misfire. So these kind of backfire means that flame traveling backward instead of going forward. The flame should go from engine to exhaust, but if it goes from engine to cylinder, imagine what kind of problems will occur. So those kind of things should not happen. So these are some of the technical issues which require a lot of research. So government is promoting hydrogen in a very big way. Recently, they unveiled a roadmap of demonstrating hydrogen vehicles also for power generation, and they are putting a lot of investment. So Ministry of New and Renewable Energy has released the hydrogen roadmap in the interim, and lot of activities going on. Another fuel of interest is the hydrogen CNG. Now, I'm talking about hydrogen CNG is a blend of hydrogen and CNG. This is also allowed in India as an automotive fuel. What is the advantage? Advantage is you get to use hydrogen and CNG together. This hydrogen CNG has a unique advantage that it can reduce even NOx emissions. The drawback of CNG is that NOx emissions are not reduced, but when you blend hydrogen into that, NOx emissions are reduced, and you can use hydrogen for urban mobility. So this becomes like an advantage. So that you are using hydrogen at the same time, you are also using a safe fuel like CNG. So the one can say the danger of hydrogen is reduced by CNG, and you get best of both worlds. You get the advantage of hydrogen and safety of CNG, and at the same time, you get benefit of lower emissions. Because when you are increasing hydrogen, means blending hydrogen with CNG, in effect, what you are doing is you are changing the H/C ratio, means more hydrogen, less carbon. And because of that, the hydrocarbon, HC, and CO emissions are lower. And that is another advantage. So this technology is ideally suited for CNG buses. And that is where the work right now is going on. So environmentally, HCNG is far superior to CNG, and it reduces emissions further and helps in terms of bringing in a cleaner fuel in the market. So ARI, we did a lot of work on hydrogen CNG along with the Indian Oil, and we ran different engines on hydrogen CNG, and we got very good results. Currently in Delhi, there is a pilot project going on where the DTC buses are being converted. So in one depot of DTC, the CNG buses are now running on hydrogen CNG, and that particular station was only inaugurated last year, and the pilot project is going on. And once this is successful, they will go for full-fledged conversion of all the hydrogen CNG stations to hydrogen CNG in Delhi. So this is the update. Then coming to the fuel cell. So what is fuel cell? Fuel cell is nothing but like a battery, but it is a gas battery, one can say. So you use hydrogen to generate ions, and that ions produce a current. So just like a battery produces a current, you have a cathode and an anode. Similarly, the fuel cell also will produce a current, but the current will be generated through ions, and there will be a membrane which will allow the diffusion of certain ions. So the hydrogen ions will go to the cathode and the oxygen ions will go to the anode, and both will then join together, and there will be water produced and current produced. So the fuel cell produces current, water, and heat. These are the three outputs of the fuel cell. So you take in hydrogen, you take oxygen from the air, and then you produce water, electricity, and heat. Now, the electric vehicles can also use fuel cells because these are just like batteries. But you need to have a hydrogen fuel system on board. That is the only constraint. So this is a typical fuel cell bus system wherein you have different subsets. So one is the hydrogen station, then the storage container, the regulator, the delivery system, the fuel cell stack, and then the remaining part is just like an electrical vehicle where you have motor, batteries, and all those things. So this is how a typical system will be. Now, government has introduced a standard, safety standard, AIS 157, for approving hydrogen and fuel cell vehicles. So this safety standard is already available, and you can see this. This is available on ARI website, and the government has already notified this particular standard. Now, the contents of this standard is all the safety aspects of fuel cell vehicle, including the receptacle, nozzle, storage system, components, the stack, and the electrical vehicle. So all these standards and rules and regulations are available for fuel cell vehicles. So these vehicles are also now going to be developed in a big way, and more vehicles will be introduced in the future. Now, coming to another technology of the future, the last bucket of alternate fuel is the synthetic fuel. Now here there are different technologies, DME, Fischer-Tropsch, syngas, but I will only talk about DME because that is the notified fuel. So remaining others are still in the infant stages. So this DME or dimethyl ether is a synthetic fuel. It is an alternative to diesel because it's having very good C10 number, and it is gas at atmospheric condition, but it becomes a liquid when pressurized. And it is having very low emission in terms of emission content, and it has definitely requires very little after treatment, doesn't require particulate filter, because PM, NOx, smoke, all emissions come down when you use DME. This is very good fuel, clean fuel. So government is actively promoting DME, and hence DME is now notified for automotive fuel. This came only last year. It's a very recent phenomenon. And there are standards and rules for DME in India. So the international standard is ISO 16861, which India has adopted. And different rules as far as certification are also provided for the DME vehicles. DME is also popular in Western countries. Countries like Sweden is there, then other in Japan or some in Germany. There are some Volvo engines or Scania engines or Chinese SAIC engines which are running on DME, and many such vehicle and applications are already available worldwide. India also, we are working on that, how we can generate DME engines in the future. The challenge for the DME in terms of that, you require larger tanks, you require design modifications, and many such things are required. It's not so simple to use directly as a CI engine fuel. Many challenges are there. And again, in terms of the supply lines, you have to use pressurized supply line, high vapor pressure is there, then gasket and material compatibility issues are there, combustion development issues are there. So there are some issues with DME, and these have to be overcome as we go along. Then as far as emission is concerned, people did a lot of work on this, and they found that emissions are very less. As far as DME is concerned, it is very easily meeting all kinds of requirements and it is very, very clean as compared to gasoline. This is some data from Isuzu and Volvo, and they say that DME is one of the cleanest fuel which is known to them. It is widely used for diesel engines, is widely used for many applications, and definitely an engine fitted with EGR has a very equivalent characteristics to CNG, and hence it is very much recommended. Another application of DME is that you can blend it with LPG, and you can also use it as a cooking fuel. So there is a LPG shortage. So people are also exploring, can we use DME as a cooking fuel, and can we blend it and then use it for different applications. So this is as short as the different alternate fuels is concerned. And everywhere, I will say the research and development is definitely the key for adaptation of alternate fuels. So one can say that in any fuel, if you really want to use it, first you have to do the fuel characterization. Then you have to do the engine studies on the fuel. You have to do vehicular trials. You have to do material compatibility. You have to worry about the vehicular emissions. And all of this R&D is required. Then only the fuel can be made available for application, and any commercial development will require all of these aspects to be covered. So we at ARI have been working in this area many years, and we have all the facilities required to do this kind of analysis. So this is the gist of it, and with these technologies, one expects to achieve the vision of clean fuels for the environment. Because all the technologies which are discussed so far are alternatives to fossil transportation. So why we are worried with diesel petrol costs? Because the major transportation belongs on that. And when the cost of crude oil increases, the cost of diesel petrol increases, and then the entire market chain is affected because all the inflation, price rise is linked to fuels. And hence everything, all the common person gets affected because his budget goes for a toss, because he has to spend much more money for buying the fuel. So it is very important that all these alternatives are researched and all these alternatives are made available, so that the common person has a choice of fuel. And government job is to ensure all technologies are given a level playing field, and then let the market forces decide which technology will be preferred by customers. So it's the customer choice, and finally the market forces which decide the success of a particular technology. But one should not dictate technology. You should only use this, you should only use that. There should be a common ground. And definitely, as I mentioned to you in my first slide, there are three technologies: the e-mobility, the alternate fuels, and the fossil fuel, which are competing with each other, and they will compete with each other for the pie of the market. And that is how it is going to happen. And with that, I can say that I have just covered, I think, almost all the points which I have to say. So thank you for patient listening. And now I'll be happy to answer questions on the topic which I have this thing. So over back to organizers.
Thank you very much, sir. It was a session indeed filled with knowledge. With your permission, now I would like to start up the question answer session.
Sure, please.
Are there any participants who want to ask questions? They can just raise their hand so that we can unmute them. I request the technical team to kindly unmute Satyamurthy, sir.
Sir, namaskar. Am I audible, sir?
Yes, sir, you are audible.
Yeah.
Thank you. Thank you very much, sir. First of all, nice presentation, sir. For that, congratulations, sir. Sir, my question, sir, sir, you told that, while presenting, there is no need to get panic about the vehicles which are running through the fossil fuel, maybe like diesel and petrol. But nevertheless, India, we are having a policy towards 2030. We wanted to change it over to battery cars, sir. How far this time is enough for us to change or to mitigate the accommodations, sir? Is it possible, sir?
Yeah. Now, the blunt answer to a question, no. It is not possible to go to what government is initially it was saying was 30% of vehicles to go to electric by 2030. Then
Yes,
they
sir.
observed that it is not feasible at all because there are still many open points. See, they are working on electric vehicle. Any technology to really get, one can say, implanted will take a lot of years. First, you need infrastructure. So you need to have charging infrastructure in place. We don't see any charging infrastructure at present. It's very minimal. Imagine a country like India with a huge size. We have to really build the charging infrastructure. It doesn't come easy, it takes time. Second thing is batteries. Right now, we don't have a single battery manufacturing plant in India. Everything is imported from China. All the components are imported. Some localization is going on, but it is very less. So that is bigger hurdles. So in infrastructure hurdles are there. Now coming to the second part is customer acceptance. So customer is not fully accepting EVs. Like if you see, Reva is here for last so many 20 years, I believe, more than that. And they were not able to sell much in India. In fact, they were surviving by exporting. Now government focus is there on EV and all efforts are going on for that. But to really make a dent and to really change the whole fabric of our transportation requires time. And please understand, petrol, diesel, although the cost is very high, still many applications are dependent on petrol, diesel only. Now we are only talking automotive and electric penetration in automotive. What about non-automotive sector? For example, off-highway, tractor, construction equipment vehicle, railway, marine, they also use engines and they require diesel gasoline. So those applications will continue like that. And there is one forecast by the IEA, International Energy Agency. And they say that the crude oil consumption in the future will increase, not decrease. So that is their forecast. So means that what happens is, I'll tell you, the growth of mobility is there. So the pie is also increasing. So even though the electric percentage of electric vehicles will increase, so also the pie is also getting bigger. And whatever the electric cannot cover will be covered by the remaining technologies. So their share will also increase. So everything will increase, please understand. Nothing is going to decrease. And all the technologies will coexist. There will be alternate fuel, there will be fossil fuel, and there will be electric vehicle also. But one cannot claim that a particular technology will take everything. Nothing will like that will happen. Okay. And even in alternate fuel, all different fuels will coexist. CNG will coexist, biofuel will be there, hydrogen will be there, synthetic fuel will be there. So different applications will use different fuels. So there is really, to answer your question in very short, I don't think that achievable to go fully electric by 2030 is not possible at all.
But some of the companies already they started manufacturing the battery operated cars.
That manufacturing has started. They will introduce those vehicles, no doubt about it. Their population will also increase, but it is not going to be 100%. That's my question. What these people say that the IC engine will disappear, no more fuel, that thing won't happen. Electric vehicle will increase, no doubt about it. But the share of the total market will increase, electric market. But the total market is also increasing along with it. That's what I'm saying. So other technologies will also increase along with it. Yes.
Yes, sir. Sir, maybe one more question, sir. Sir, recently our Prime Minister announced that, there must be a blend of ethanol.
I mentioned that 20% blend. Yes.
That's what, sir. But ethanol, even distilleries and all, they are selling it for other purposes, and they are almost earning money as well.
Right.
How come this policy, whether it is strictly implementable, sir?
Actually, what I think you must have missed that part, but I mentioned that traditionally we are looking at ethanol only from sugarcane, right?
Sugarcane.
Now what we are looking for ethanol from other sources like damaged food grains. Damaged food grains are the ones which are rotting in the storehouses, warehouses, right? Which cannot be consumed. So that damaged food grains will now be diverted to ethanol. Okay, that is one additional. Then excess sugar which is there, because if we are producing much sugar and sugar prices are dropping, so the excess sugar also can be converted to ethanol. That is another technology. So they have allowed this, And in addition, they are using 2G ethanol, 2G, 3G, that is biomass-based ethanol. So sugarcane ethanol is continuously rising. In addition, other three sources of ethanol are coming. So they are wanting more and more ethanol to be made available. Okay, then they will try to go from 10 to 20%. As far as the other industries are concerned, you are talking about breweries and pharmaceutical, right? So
Yes,
those
sir.
are having their fixed ethanol consumption. They give better money. That's why the ethanol producers go there. But like
Yes.
they will not be using other sources. So the damaged food grains and all that things will be diverted to the fuel blending. So what government wants to do is generate surplus ethanol capacity so that blending will improve. That is the whole idea. That is the policy which they have recommended.
Sir, sir, sorry for the inconvenience, sir.
Yeah.
Sir, actually going with the rotten food grains, of course, but anyhow, those data, whether it is available, because, government, they are not revealing that. Even in Tamil also, we are facing the problem.
They don't share that data.
Because it will become public problem, sir. Because, after producing, putting effort, farmers putting effort, when they are wasting it, it will become the point of the discussion, or maybe opponent parties, they make some the question out of it, sir. But anyhow, how do we collect this data, sir? Maybe again,
actually, we don't have that because the oil companies have that data and Ministry of Petroleum has that data. But they are not talking about conversion of good quality food grains to fuel, food versus fuel debate. So that won't be there. Only the spoiled grains, excess sugar. Because in the interim, what happened became that the sugar lost the price, and the byproduct ethanol became more valuable than the main product. So the focus shifted to ethanol rather than sugar. So even there are some technologies which I heard that they can suppress the sugar production and increase the ethanol yield. So they are doing those kind of thing in sugar factories. So that is what we are talking about.
Thank you, sir. Thank you for giving the good insight, sir.
We have one more participant, Milind Patil, sir. Can you unmute yourself?
Hello.
Milind Patil, sir. Yes, sir. You are audible.
Am I audible?
Yes, sir. Yes, sir. You are audible.
Yes, you are audible.
Very good afternoon, sir. Very nice session. I was looking for such a sessions, and also I attended one of the SAE workshop. There I listened you. Again, I am asking one more question, sir. Here.
Yeah.
The information was very clear and concise, sir. I'm happy with that. I would like to know that, sir, is it possible that I can blend two different kind of biodiesel like Jatropha and Karanza, and their proportion is to be mixed with the diesel? Will it be helpful or not?
Yeah, it will be. Actually, any biodiesel is helpful, provided that the quality requirement of that biodiesel is met. So if we see whatever biodiesel you are producing has to meet the Indian standard 15607, IS 15607. So if your fuel is meeting that requirement, then you can blend it along with diesel, no problem. Even if you use two different feedstocks, that is not an issue. But your end product, the biodiesel which is prepared by blending those two feedstocks, that end biodiesel has to meet the quality requirement. If that meets the quality requirement of 15607, then you can use it in the engine or vehicle, no problems.
Yes, sir. Sir, one more question, please. Biodiesels are enriched in oxygen content. So, that actually causes the NOx emission.
Yes, you are right. Yes, actually, there are two things. What happens with biofuel is, because of the extra oxygen inside the fuel, there are oxyhydrocarbon species produced in the exhaust, which don't come with diesel, gasoline, or gas fuel also, gaseous fuel also, PNG also. So these aldehyde ketones are generated, and the other phenomenon, as you rightly said, NOx will increase. Because what happens is, you have excess oxygen now. You have oxygen from air and you have oxygen from fuel. So you will have to worry about NOx control. There are multiple ways. You can reduce temperature by some cooling. Then you can use EGR. Then you can use after treatment, NOx after treatment. So you can use some either catalysis or any other kind of SCR or something. With that, you can control NOx. But NOx is an unavoidable emission. That
Yes,
is
yes.
absolutely right. You cannot suppress it, but you can control it.
Yes, yes. Sir, one more question. Maybe I don't know whether it is hello. Am I
Yes,
audible?
go ahead, go ahead. Yeah, you are audible. Go ahead. Go ahead.
Sir, I read means recently I read some articles, research articles. There they are using a neural network for the prediction of the CO emissions on NOx emissions.
Yes, yes.
So, is it good thing that we can go for use of neural network for these predictions?
You can. Neural network is nothing but something which is a predictive method. So you
Yes.
just make an artificial network, you train that network, and then you predict it. So it helps to reduce experimentation. It's just like simulation, it's like a prediction technology.
Yes, yes.
So if you don't have time for experimental work, you just build a model, validate that model, and then you extrapolate that model for some conditions which you will not physically test. So that is the whole idea.
Yes, sir.
I mean,
Thank you, sir. Thank you.
It's a valid tool, yes.
Yes, sir. Thank you, sir. Thank you.
Hello, sir.
Yeah,
So there is one more question from one of the participants.
sure, please.
Will blending increase the cost of engine modification?
Will blending increase the cost of engine modification? No, I don't think so, because blending is a different thing. No, so you are adding another fuel to the basic fuel. So if the blend percentage is low, there is hardly any change in the engine parameters. But if it's a very high blend, then perhaps maybe materials might have to be changed. For example, when you talk E85, ethanol 85%, flex fuel vehicle as you are talking. So there, lot of changes in the engine will be there. Materially, also the operationally, calibration will change. But if it's only E10 or E20, not much change is expected.
Okay. Sir, from one more question from Mr. Basparaj.
Yeah.
He asked that will the greenhouse how will be the greenhouse gases emission as compared to the normal fossil fuels for the alternative fuels?
It is very less. Actually, I didn't put that slide because there's limitation of time. But all the alternative fuels reduce greenhouse gas emissions. CO2 is less. Because first of all, biofuels are carbon neutral, I told you. So the whatever emission of CO2 is there by the biofuels gets minus because it has already absorbed CO2 from air. So that becomes zero. So they are treated as zero CO2 emission. So that is number one. Second thing is regarding the other fuels, the CO2 emissions are far lower than fossil fuels because fossil fuels generate a lot of CO2. So definitely it is low.
He also asked about the cost factors for the alternative fuels as compared to the fossil fuels.
It is less. All the what you call alternative fuels are cheaper. Like as I mentioned, CNG is hardly 40-50 rupees as compared to your petrol, diesel. Petrol is now 100 plus. Diesel is 90 plus. I think some places diesel also crossed 100, I believe. And then biofuels, your ethanol is 45 rupees. Now latest rate is I think 50 to 60 they are giving now. But ethanol is around 50, 60, CNG is around 40, 50. Your this methanol is 20, 25 rupees. Then your DME, you can bring it down as low as 30 to 40 rupees a kg. Then your hydrogen is only expensive because that is something which is artificially produced. So electrolysis hydrogen is around 200 rupees right now. But I think with the way the diesel prices are increasing, even that hydrogen price, since it is not in a big production, once it goes in mass production, hydrogen price will come down and diesel price will continue to rise like this. So one fine day, they might meet also. So then in that case, even hydrogen may be cheaper. But 90% of all the alternate fuels are cheaper than fossil fuel.
So there is a question from Prem Kumar Joshi, sir.
Yeah.
He is asking, what about the BH parameters after blending?
What about the
BH parameters?
DH?
BH.
DH. I'm not getting the question.
BH, sir. BH parameters. I think he is focusing upon the Bharat, those parameters.
BS.
Yes,
Okay.
yes.
You mean emission levels? Okay.
Emission level.
The talk like that. Now, emission levels, all the alternate fuels are meeting BS6 with only one after treatment. So example is for a diesel to meet BS6, you need DOC, DPF, SCR. But in a CNG case, we only use one 3-way catalyst to meet BS6. So they need very little after treatment and they easily meet BS6. Hydrogen can meet anything. It can meet even BS7, 8, 9, 10 whenever it comes. Now there is Euro 7 being talked about. So there might be some BS7. So hydrogen will meet everything because it's zero emission practically. Yes.
Okay. There is one more question from a participant. He is asking, is there any commercial vehicle which is running on DME?
Commercial vehicle. In India, no. But in Sweden, yes. Sweden is running. There are buses and trucks running on DME.
Okay. Are there any other participants who wants to ask questions? They can raise their hand so that we can unmute. Okay, so I think there are no questions.
Yes, sir, we have one question.
Yes.
On a WhatsApp. We request you to please check.
Yes. So, sir, one participant has asked about how to filter the biomethane.
Filter the?
Biomethane.
Filter the biomethane. Okay, that is purification. See, what happens is biogas, when you take, see, it is fermentation. So you take biomass, which is nothing but garbage, everything, you produce biogas. Now, as you rightly said, you have to filter out the impurities, right? So there are 3 impurities which I mentioned. One is the hydrogen sulfide, which gives the odor to that biogas. Second is the moisture, that is water. And third is the carbon dioxide. Okay. So all these 3 have to be removed. If you do not remove CO2, the calorific value of biogas will suffer. If you do not remove H2S, corrosion will happen because H2S will form sulfuric acid and it will corrode the engine. And moisture, you know, it reacts with hydrogen sulfide, right? So all 3 are not required. So what you do, you first pass the biogas through a absorber, something like a silica gel, which will absorb the moisture out of it. First of all, you remove the moisture from the gas, you make it dry. After you dry the gas, then you pass it through limestone column. So you wash it with limestone water. Now the gas comes from top and the water comes from below, or either way, gas can come from below and the water can come from top. So you have a counterflow arrangement and you wash the biogas with the limestone water. And with that, what you do is you remove the hydrogen sulfide. Okay. Then last is CO2. So you use pressure swing adsorption technique or chemical absorption technique. You use some cartridge. So with that, you absorb the CO2. And then what remains is only methane. So that is called biomethane or CBG, or it's also called as the biogas. So it's a biomethane. It's not biogas anymore because the impurities are gone. Then that biomethane has to be compressed to 200 bar and then stored just like CNG. So it becomes CBG or bio-CNG. We call it like that, bio-CNG. So that is the process. You first remove the hydrogen sulfide, you first remove the moisture, then the hydrogen sulfide, then the carbon dioxide. So there are multiple techniques of removing this. Is it clear?
We request Komal Patel to mute the mic if she has no question. Okay, thank you.
Yeah.
I think Satyamurthy sir has raised his hand.
Sir, maybe only one. Sir, when we go with the 30% replacement with ethanol, sir, even though it is hypothetical, but how much price can reduce, sir? Now it is already 100 rupees, sir.
You are talking 20% ethanol, you are saying.
Right, that's what, sir. When we go with the blend of at least 5 to 20%, sir, how much you can able to see that, how the price reduction, how much?
What happens, I'll tell you. Ideally, price should go down. But it is up to the government to pass on the benefit to the customer. Unfortunately, it doesn't happen.
Yes,
you
sir.
understand what I'm saying, right?
Yes, sir.
Because
I understand. Sir.
Ideally, ethanol is cheaper than gasoline. So when you blend 20%, ideally the cost should go down. But
Yes, sir.
the actual fuel cost is only 30 to 40 rupees. Are you aware?
Yes, sir.
And
Yes, sir. Yes, I understand.
remaining 60 rupees is taxes
Taxes.
of
Yes, sir.
central government and state government, which both do not reduce. Just
Okay,
now,
okay.
yesterday only the minister issued a statement, we are not going to reduce taxes. So
Yes, sir.
that is why the 100 rupees, okay? So
Yes, sir.
actual
Yes.
fuel price is only 40, 60
40.
rupees
Yes, sir.
taxes. And no government will reduce the taxes because that is their income, right? So
Yes, sir. Yes, sir.
if
Thank you,
that,
sir.
to answer your question, the benefit is not passed on to the end consumer, unfortunately.
Yes, sir.
Yeah.
Yes, sir. Thank you, sir.
Any other participants? If they want to ask questions, can raise their hand. Okay, so if there are no questions, I conclude the session here, session 12 here, and I request all the participants to be in the meet as we start up with the validative function of our Sttp. Mukund sir?
Yes, sir. We can start with the
Can we
validatory.
proceed?
Yes, sir. Sure, sir.
Okay. To improve the golden moment of opportunity and catch the good that is in our reach is the great art of life. A very warm welcome to one and all present in the meet. It gives me an immense honor to invite the dignitaries on the virtual dais. Our chief guest, Dr. S.S. Chipse, Honorable Principal Dr. Sanjay Bokade, Vice Principal Dr. Sanjay Deshmukh, Head of Department Dr. Rajesh Kale. I welcome you all and thank you on the behalf of the Sttp team for joining us today. It's been a week full of learning for all of us from the knowledge and experience of eminent speakers. I request our Sttp coordinator, Professor Mukund Valse, to report the recap of the Sttp. Over to you, Mukund sir.
Thank you, Professor Rehan. Good afternoon to one and all present over here. Our chief guest, Dr. S.S. Chipse, sir. Principal of MCT's Rajiv Gandhi Institute of Technology, Mumbai, Dr. Sanjay Bokade, sir. Vice Principal, Dr. Sanjay Deshmukh, sir. Head of Mechanical Engineering Department, Dr. Rajesh Kale, sir. All heads of departments, my colleagues, and dear participants. It is my immense pleasure to share with you that we have received around 460 registrations for our short-term training program on recent trends in renewable energy sources and application, which is scheduled from 5th of July to 10th of July. In our Sttp, we have scheduled 12 sessions in a 6-day time period of distinguished speakers from all over the India. I will quickly brief about all the sessions. On the first day, dated 5th July, it was started with the inauguration with the chief guest, Dr. G.N. Kulkarni, sir. He is a director of Pimpri Chinchwad College of Engineering, Pune, followed by a session first on the topic solar energy utilization, challenges, opportunities of research enterprise. Session 2 was conducted by Mr. Pranav Ambaselkar, sir. He has given good information about the topic power generation from geothermal energy using organic Rankine cycle. On 6th of July, session 3 was given by Mr. Ashok Saraf, sir, who is Technical Director, Syslab Automation Private Limited, Pune, and deliver a talk on the renewable energy from a bottom of pyramid. Session 4 was given by Dr. Hitesh Panchal, sir. He is a professor at Government College of Engineering, Patan, Gujarat, on the topic of solar steel. On the 7th July, session 5 conducted by Mr. M.S. Thakare, sir, who is professor at PVG College of Engineering and Technology, Pune, and given a good insights on the topic of renewable solar cogeneration system. Session 6 was conducted by Dr. N.M. Bhatt, sir, professor at LD College of Engineering, Gujarat. He has given a good information about the topic development of energy efficient, low cost solar air heater. On 8th of July, session 7 conducted by Dr. Zakir Hussain, who is professor at IIT Bombay and deliver a talk on the topic of renewable energy integration. Session 8 was given by the Mr. Abhishek Masurkar, who is director of Typro Private Limited and alumni of Rajiv Gandhi Institute of Technology, and he has given a good insights on the topic of sustainable way of green energy maintenance. On 9th July, session 9 conducted by Dr. Prakash Gade, sir, who is professor at MIT WPU Pune. He has delivered a talk on the topic solar power tower technology using a ray tracing software, Soltrace. Session 10 was given by Mr. Milind Dahigaonkar, sir, who is a founder of Army Associate, Pune. He has given a great information on the topic of design consideration in the electrical systems of cogeneration plant. Today morning, on 10th of July, session 11 is conducted by Mr. Avdut Dikshit sir, who is Energia Consultant Pune, has delivered a talk on the topic of project management of solar PV small medium-sized projects is installation and commissioning. Currently, session 12 was given by Dr. S.S. Sttp sir and given a good insights on the topic of alternating fuel technologies and regulations. We are very thankful to all the eminent speaker and all the participants for joining in our short-term training program to make our STTP grand success. Thank you, everyone. Thank you so much. Over to you, Rehan sir.
Thank you very much, sir. A pessimist complains about the wind, an optimist tries to change it, and a leader adjusts the sails. The sails for this particular notion were adjusted by a person who is a great motivator to all of us. The person who gave us the belief to bring together this event. He is none other than our beloved HOD. I take this pleasure of requesting our HOD to address the participants. Over to you, Kale sir.
Yeah. Thank you very much, Rehan sir. Good afternoon to all present here on this virtual platform. Today's distinguished guest for the validatory function, Dr. S.S. Sttp sir, who is Senior Deputy Director at ARAI Pune. All the HODs who are present here, Honorable Dr. Sanjay Bokade sir, unfortunately he has some work, that's why he could not attend this function. The co-coordinator of the STTP, Professor Mukund Varse sir, the STTP team, Professor Rehan, Professor Poor, and all the students of RGIT who are helping in the organization of this STTP, and all the participants participating from various parts of India. Renewable energy and its application is an important topic which has a potential to change the economics of a region. Still, much needs to be done in order to exploit the fullest potential of renewable energy. In this context, this STTP was very much important, wherein we had talks by renowned speakers on various topics, which explained the basics of renewable energy. And we had some topics which had, which explained the technologies and products in the area of renewable energy and on the topics having research potential. I thank the management of the institute and Honorable our Principal Sir, Dr. Sanjay Bokade, for giving permission to organize this STTP. At the same time, I must congratulate the STTP team led by Dr. Kiran Chaudhary Madam, Professor Varse, Professor Rehan, Professor Poor, and all the RGIT students who are involved in the organization of this STTP. I thank Dr. S.S. Sttp for giving his consent to be the guest for the validity function, and I also congratulate and thanks all the participants who must have got something valuable from this STTP. Thank you very much. Thank you, sir.
Thank you very much, sir, for your influential words. The fragrance of flowers spreads only in the direction of the wind, but the goodness of a person spreads in all directions. We are delighted to have with us Dr. S.S. Sttp as the Honorable Chief Guest of our valedictory ceremony. I would like to call upon Professor Mukund Varse to once again introduce our Honorable Chief Guest to all of us. Over to you, Mukund, sir.
Thank you, Professor Rehan. Dr. S.S. Sttp has done his master's in thermal science from the Bardley University, USA, and his PhD from New Jersey Institute of Technology in the field of alternative fuel combustion. He has rich experience in research of 23 years in the area of alternative fuels. He is a Deputy Director and Head of Engine Development Laboratory at ARAI. He serves as a member in the Expert Committee of Alternative Fuels of Department of Science and Technology, DST. He is a Chairman of National Standard Committee of Gasoline Fuels. He is a Governing Board Member of SA India Western Section, Life Member of Combustion Institute and IST. He has published 14 books and has 6 patents on his credit. He has 100+ publications in national and international conferences and journals. He has won 3 awards for the best technical paper in the international conference. Over to you, Rehan sir.
Thank you, sir. I now invite our Honorable Chief Guest, Dr. S.S. Sttp sir, to address the participants. Over to you, sir.
Yeah, thank you for the kind words. And it has always been a pleasure to associate with the academic community. And today I'm honored that you have invited me as a chief guest for this valedictory function on such an important topic of renewable energy. So renewable energy is one thing which is very important today, and the importance of renewable energy is increasing in the future also, because we are all grappling with the energy crisis, that our fossil fuels are running out, our fossil energy sources are causing pollution, and we have to really address these global concerns. And for that, work on renewables is paramount. I didn't cover about solar and other things, but there's a lot of work being done on solar, wind, then the tidal energy, geothermal energy. All this is, one can say, is a sustainable forms of energy, because this is coming for years together, millions of years. The sun is around and solar energy is abundant, and we should take advantage of these perennial energy sources. And the biggest advantage of renewable energy is that it does not damage the environment. Even if you harness renewable energy, it is in sustenance with the environment. Any technology which will coexist with environment and not damage it is the only one which will survive in the future. So if you are having a technology which will repair the damage or will not do any further damage, that is very much desirable. So all renewable energies actually are the ones which are restoring the ecological balance which has been damaged by the use of fossil fuels and all those things. So that is why this topic is very important. I'm very happy to be here, and always a pleasure to talk with the academic community to inform them about what is happening in terms of new technologies, because as you know, we are living in a very exciting time. The lot of technologies are now being developed, being talked about, and India is also in the, one can say, a revolution as far as the technology is concerned, and lot of new technologies being developed in India itself, and some being imported, some being used, some being exported outside also for that matter. And so it is a very exciting time, and I see that in the future the renewable energy component in our energy structure will keep on increasing. More and more focus will come. And I compliment RJIT for doing this workshop. This is a very timely time for doing such kind of event, and definitely one must spread awareness about all these technologies to young minds, because many of you are future leaders. Some of you will take up some roles in different aspects. Some may be entrepreneurs also. Some may be doing jobs in certain areas, but everywhere there will be some renewable energy component associated. So this is an important topic from future point of view. So I compliment again all the team, and again thanks for inviting me here. It's always a pleasure. And with this, I will conclude my remarks. Thank you very much.
Thank you very much, sir, for sharing your deep knowledge with us. Your words were full of enthusiasm and valuable knowledge. No matter how good we deliver, but the inspiration to do the best remains incomplete unless we get feedback from the end consumer. I therefore request few of our participants to give their valuable feedback about the entire event. I request the technical team to unmute some of the participants who want to give their feedback. Over to the technical team. Are there any participants who want to give the feedback? They can raise their hand.
Hello. So is it audible,
Yes,
sir?
Yes, sir, you are audible.
So this is Dr. Virbadrappa from Reva University, Bangalore. I was the part of for this session, for all the sessions I have attended. There are many good resource persons you have identified, and they have given a very wonderful presentation through which we have got a lot of knowledge, especially on the solar energy. So a lot of aspects has been covered. So thank you for giving this opportunity to attend, to share the knowledge, or to gain the knowledge from this platform. So it is a wonderful platform. Thank you for us providing this opportunity. Thank you.
Thank you, sir, for your kind words.
This is Satyamurthy from Kumaruru College of Technology, Coimbatore, sir. Am I audible, sir?
Yes, sir, you are audible.
Thank you very much, sir. Sir, whenever we attend any Sttp or FDP, we would like to focus on some of the points like how the sessions are planned and who are all the speakers, all those things. But I personally, congratulate along with my own the attendees, for nicely taking up this session. All the 12 sessions are highly informative, sir. And we could be able to see the meticulous planning behind the organizers by inviting many academicians as well as industry officials. So for that, I sincerely appreciate on behalf of all the attendee participants to this virtual mode, sir. The number two, which I really admired, the WhatsApp updation for every session. And also usually when we are attending to virtual media, most of the time, fag end of the sessions, people will start asking about the feedback. But organizers made in such a way that, the feedback will be given in WhatsApp so that they can concentrate on the lecture. This idea, whoever has done it, they receive kudos for this. Thank you very much. Because, the last minute hurdle of not filling the feedback, all those things, you took away from our mind and then, made us to attend all the sessions with full of concentration. And the third important thing, which I personally believe is the enough time, ample time was given for Q&A. And moreover, all the faculty members and also the industry personalities who does the gathering, they were all patient enough to even answer some of the silly questions. Even I myself might have been posted, but they were all patient enough to give the technical answers for that. I really admired because, the organizers, they will restrict the, the timeline for the lectures as well as, enough time for the Q&A. I really admire that. And also, the technical team, whenever we raise hand, you will be unmuting, giving the privilege of unmuting and talking to the directly to the professors as well as industrial expert, which is one of the finest part, I personally believe, sir. The last thing, I could able to see the perfect blend of industry as well as academicians in the virtual Sttp. I hope I am attending the third session, maybe along with your esteemed institution. At this thing, sir, once again, I wanted to pay my deepest gratitude on our personal behalf and also our institution behalf for giving this opportunity to learn some of the good things, especially in the renewable energy area. Thank you very much, sir.
Thank you very much, sir, for your appreciating words. We have one more participant, Sumit Majumdar, who has raised his hand. I request the technical team.
Am I audible, sir?
Yes, Sumit, you are audible.
So good afternoon, everyone. My name is Sumit Majumdar. I would like to give a feedback that as I first got to know about this session, I was very much interested to join this, learn and understand the concepts from such experienced speakers who have worked immensely in this field. It was very interesting as every speaker started with the basics. So the audience, each of the audience or the participants are in line before divulging into details. And it was also very interesting as they also answered many questions and we also got to learn from them. They also gave us many ideas for our research and projects. Also, I would like to mention Mr. Mashurkar, who started his own company in very short period of time, and he has truly inspired many of the students to start this venture. And I'm very much interested to join further sessions as the Sttp programs. And thank you very much for organizing and coordinating this event. Thank you, sir.
Thank you. There is one more participant, Dr. Anita Nene.
Yes, sir. Thank you. Mechanical Department of Rajiv Gandhi Institute of Technology, Mumbai had arranged short-term training program on recent trends in renewable energy sources and applications very nicely. On this platform, all have gained knowledge from experts in different aspects of renewable energy, such as solar PV, solar thermal, wind turbine technology, design of electrical system, project management, alternative fuel technology and regulations, and so on. I have also the same, my research area is also a solar thermal energy, and I am so much delighted that I have gained so much knowledge last week. I congratulate all who were involved in organizing this informative, excellent workshop. Thank you very much.
Thank you, madam, for your kind words.
Yes.
We have Mr. Abdul Dixit who has raised his hand. I request the technical team to unmute him.
Yes, good afternoon, everyone. Thank you very much, Dr. Rajiv Gandhi technical team, Rajiv Gandhi Institute of Technology, and their team to arrange such wonderful experience. And I'm really glad that we could hear such eminent speakers. Otherwise, to meet them, it is very difficult. And thanks a lot once again for keeping on one platform for such a long time. Thank you very much.
Thank you very much, sir.
Sorry to interrupt you, Rehan sir.
Yes, sir.
I must tell the audience that Avdut Dixit sir was actually one of our resource persons, and I am very happy to tell you that he attended all the sessions.
Yes,
apart from being the resource person for the Sttp. Thank you very much, Dixit sir.
Sir, thank you very much for giving us an opportunity to attend everything, because it was such a knowledgeable experience.
Okay.
I'm really happy for that. Thank you very much.
Thank you, sir. Over to you, Rehan. Okay.
Yes, we have one more participant who has raised the hand, Mr. Manvendra Vashist. I request the technical team to unmute him.
Yeah. Am I audible, sir?
Yes, sir, you are audible.
Thank you, sir. Thank you so much. My name is Dr. Manvendra Vashist. I am from Pillai HOC College of Engineering and Technology, Rasaini. First of all, I want to congratulate the RGIT entire management and organization team for such a wonderful session. I thoroughly enjoyed all the 12 sessions on the different renewable energy sources. I have one doubt. It is better slightly if you have one session on hydrogen energy also, because I am working on this field from last 25 years with collaboration of IIT Bombay, and one of my great friend, close friend, Dr. Jakir, also produced some inside information during the 4th or 5th day of the session. Thank you so much, sir, and thank you so much.
Yes, sir. Thank you, sir. So if there are no participants, let's proceed further. Gratitude is the fairest blossom which springs from the soul. As we come close to our valedictory ceremony, I now invite Professor Paul to propose the vote of thanks. Over to you, Paul, sir.
Thank you, Rehan, sir. Am I audible?
Yes, sir, you are audible.
Yeah. Very good afternoon to all. It is my privilege to propose vote of thanks on this occasion. I, Professor Parmeshwar Paul, on behalf of MCT's Rajiv Gandhi Institute of Technology, Mumbai, and Department of Mechanical Engineering, and on behalf of Organizing Committee of Online 1-week short-term training program on recent trends in renewable energy sources and applications, and my own behalf, extend a very hearty vote of thanks to respected, distinguished, and eminent speaker, Dr. S.S. Tipse, for accepting our invitation as a resource person and chief guest for today's valedictory function, for giving wonderful session in the morning and sparing his valuable time with us. Thank you so much, sir. We are very much thankful to management of MCT's Rajiv Gandhi Institute of Technology, Mumbai, and our beloved principal, sir, Dr. Sanjay Bokade, for giving us opportunity to organize such a great and successful program at our institute. We are also thankful to our Vice Principal, Dr. Sanjay Deshmukh, sir, and Head of Mechanical Engineering Department, Dr. Rajesh Kale, sir, for constant motivation and guidance throughout the Sttp. I would like to express my sincere thanks to our Sttp coordinator, Dr. Kiran Chaudhary, madam, for her wholeheartedness, profound and strenuous work. Thank you very much to our all eminent speakers who spent their valuable time with us and shared a great knowledge and lifetime experience with us and with all the participants. Hope all these sessions will be helpful to all of us in future. I express my sincere thanks to all our participants who participated actively in all the sessions during the complete Sttp. I hope you all have benefited from this Sttp. I am thankful to our organizing team, Professor Mukund Walse, sir, Professor Rehan Siddiqui, sir, and our technical team, Mr. Akash, Mr. Hitesh, Mr. Ankit, Mr. Rahul, and our anchoring team, Mr. Yash, Ms. Yashika, Ms. Ishika, Ms. Vaishnavi, Ms. Rutuja, Mr. Mas, and Mr. Pranay. Last but not the least, I am thankful to all my colleagues, teaching as well as non-teaching staff members of our institute for all the supports during the Sttp. It would not have been possible without everyone's support. Thank you all. Thank you very much. Now we will conclude the valedictory function with national anthem. I request everyone to stand for national anthem. I request our technical team to play the national anthem. Technical team.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
The end of a story is the new beginning for many others. On this note, let us conclude a remarkable, memorable, and knowledgeable valedictory session. On behalf of the entire team of the Sttp, I sincerely thank the dignitaries for being with us this afternoon and enlightening us with their enthusiastic remarks. I shower my heartfelt gratitude to all my colleagues and all our dear participants for their wholehearted support rendered during this entire process of the Sttp. Thank you, everyone. Before we conclude, I would like to thank everyone once again. Have a wonderful evening. I now request the technical team to end this session.
Thank you so much, sir. Thank you so much, sir.
Thank you, sir. Yeah. Thank you, Tipsy, sir. Thank you. Thank you all.
Thanks, sir. Thank you very much, sir.
Yeah. Thank you, everyone.
Very much, sir.
Thank you all the participants.
Thank you, sir.
Shall we leave the session, sir?
Yes, sir. Yes, sir. Please.
Thank you.